Next problem. We got two more. 3x minus 2 is greater than 3. Yep. That's one of the more important parts. Yeah. 3w over 2 plus 1 is less than 2. We do have an and statement. I could have wrote this as a sandwich. I can write this answer as a sandwich. It is an and statement. This and this both have to be true. You have to be a boy and you have to be 15. So here we go. First problem. Move the 2 over. We now have, and I'm going to start doing this. Hopefully you can on problems like this. You don't have to show when you do plus 2. Just move it over and do plus 2. You get 5. Right? You don't have to show that step. If you get to where you can do that in your head, great. Don't show your step. The last step, x is, however, move the 3 over. So x is greater than 5/3. Makes sense. You can. If you want to change that to, that's 1 2/3, that's fine too. Yeah, because that way it's easier to put on your number line. And move the 1 over, we get 3w over 2. That's supposed to, I changed one of them to an x and I didn't change the other one to an x. 3x over 2 is less than, move the 1 over, 1, right? You could do this in 2 steps. You could get, if you don't like fractions, how do you get rid of divided by 2? You multiply by 2, so that's 3x is less than, multiply by 2, you get 2. Multiply by 2. How do you get rid of the 3? Move it over, you do. So, x is less than 2/3. So, is there any numbers, stop right here, is there any numbers that satisfy that? X is greater than 1 2/3, and x is also less than 2/3. No. There are no numbers that satisfy that, because think about it. Here's 2/3. Here's 1 2/3. I want a number that is greater than this, and it also has to be less than this. Are there any numbers that's like that? No. No solution. Good job. There are no numbers that's bigger than 1 2/3, and that's also less than 2/3. Well, you think it's easier than Aristoteles? 2x minus 4 is greater than negative 2, or, you'll always have a solution on this, because it's an or statement. It could be either or. It could be one or the other. 2x minus 6 is less than negative 2. Can we write this as a sandwich? No, because it's an or statement. Good job. Let's try to do these in our head. And again, if you get to this point, hopefully you do, well before the end of the year, you don't have to show steps. Move the 4 over. How do you move 4 over? Plus 4. What is that plus 4? 2. That's positives, negatives. Negative 2, positive 4. Which do I have more of? How many more do I have? Yeah. Last step, move the 2 over. How do you move 2 over? 1. X is greater than 1. Makes sense. Or, good job. Move the 6 over. How do you move 6 over? Plus 6. So 2x is less than 4. Move the 2 over. X is less than 2. So x is greater than 1, or x is less than 2. They would. So that's weird, because this isn't an and statement. So watch very close. This is not an and statement, but they meet like an and statement. Because x is greater than 1 looks like this. It's all the numbers to the right. Or x is less than 2 looks like this. It won't become, because let me explain why. It can satisfy either or. This is all the numbers that's greater than 1. Think about all the numbers that's greater than 1. You got 1, or not, you don't have 1. 1 1/2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to where? It don't end. It's all the numbers bigger than 1. All the numbers from 1 to this side. Correct? Or all the numbers that's smaller than 2. Think about all the numbers that's smaller than 2. 1, 0, negative 1, negative 2, negative 3, negative 4. It never ends either. So look at that. Is there any number that's not satisfied by one or the other? All the numbers bigger than 1, or, either or all the numbers that's less than 2, that is not no solution. You got tons of solutions. All real numbers. Makes sense why. It's all the numbers bigger than 1 combined with, you got a pile. In this pile, you got all the numbers that's bigger than 1. In this pile, you have all the numbers that's less than 2. Put the two piles together. Is there any numbers that's not in the one pile or the other? You got, because an OR statement, you put them both together. That's all. That's everything. So all real numbers. And here's the way that my group remembered it last year. If it's an OR statement that looks like an AND statement, because normally AND statements are the ones that come together, right? If it's an OR statement that looks like an AND statement, all real numbers. If it's an AND statement that looks like an OR statement, what would that be? No solution. An AND that looks like an OR would be no solution. An OR that looks like an AND would be all real numbers. I'm more interested in you knowing the other ones, but these are